Hey guys, thank you so much for joining me today on Danamo BIM. Today on Danamo Chats, I'm super excited. I have a panel of MEP engineers. I don't know whether that's what they would refer to themselves as, but we're going to have an MEP chat, and I'm super excited about it. You guys may know at Smith Group, I work a lot with MEP and the systems tab, which is very foreign to me. And some of these guys have been really wonderful and just trying to pick their brains, trying to understand some of the problems that they're facing, some of the things that they've discovered, and share them with you. So without further ado, today we have Majd. How you doing, Majd?
How are you, Dana? Thanks for having me. It's a great pleasure.
Pleasure to have you. You want to tell me a little bit about yourself or tell the audience a little bit about yourself and Bird Tools?
Yeah, so basically, the audience might know me as Bird Tools because I don't really have any other social media. We're a company based in Estonia that basically deal with all the MEP stuff that you mentioned. So we do a lot of customized stuff for several companies around the world, ranging from the Far East to the US. And we've worked with on a lot of standards on a lot of automation, MEP automation stuff. So that's who we are. We also have several public apps that are getting popular each day. And yeah, so I started as an MEP engineer, and due to the fact that you have a lot of repetitive stuff and a lot of boring processes, I started my own automation venture. And since I found that it's a common need for everyone, I made it public, and here we go. So now we're here.
Well, speaking of tools, when I was researching you, because I totally looked into Bird Tools and some things that you're working on, I found SpankMyRevit.
Yeah.
And I died. I literally, that like made my year. I literally, have you guys seen this? Sean and Taco, SpankMyRevit. I'm going to share it in the description with
He's
the
never
audience, but
mentioned
I'll
it to
share it
me.
in our chat right now. Oh my gosh. It's hilarious. It's essentially a button that you can install to have in Revit. And every time you get frustrated, you click the button and it spanks Revit.
That sounds like a John
Yeah.
Peterson
Totally.
fun tool too.
It's
Yeah.
hilarious.
So basically, it started as a someone. So there was that blog RevitAddons.com that posted it as an April Fool's joke, and I like the joke so much, and I turned it into a real application. So yeah.
It's hilarious. It's hilarious. I wouldn't necessarily recommend anybody go Googling it because you don't know what you'd find, but I did it and it was the first thing that came up. So
Do you guys
maybe not too
remember
many
like
crazy things.
in the old Mac, like the very first Macintoshes, like I forgot what program it was, but you could do like the explosions and like the paint.
No, I've
Maybe.
actually never had a Mac.
Oh, I wonder if this is even aging myself a little bit. All right, I'll digress from that, but that's what kind of reminds me of too.
Well, Asan and I constantly have discussions about he's a Mac person and I'm not. So we're constantly having little battles about that.
Yeah, this is like when I was in
I
like
surprised you.
elementary school,
Oh,
like in the
I
first
see.
Macs that we
Like
used,
the
and it was like the
Oregon
paint program.
Trail status.
Yeah, exactly. The black and white Oregon Trail.
Yeah.
But the race
Very
tool like blew up the screen, so that'd be nice to blow up Revit or spank it. So yes.
Spank it. Exactly. Next up of our chat, we have Taco. Taco was on here a little bit earlier on our Dynamo chats talking about his package, Me Pover. Hey, Taco, you want to tell us a little bit about yourself again?
Hi everyone. Well, my name is Taco, and I live in the Netherlands. I work for an engineering company, and I also do some freelance stuff, mostly Dynamo automation, and yeah, basically that's all I do. Most of the stuff, at least.
Lucky you.
Yeah, yeah.
Right? If only that's
Yeah.
all I did.
Yeah, I've digressed a bit from the usual project engineering.
Like actually being in production.
Yeah, having
Came onto the
meetings
dark
and stuff.
side with the rest of us, yeah?
Exactly. Yeah. Yeah. But it's not a choice that I regret in any way. And this is really the more fun stuff, you know, figuring
Yeah, the
out little.
sexy, innovative technology stuff, right?
Exactly. It's like a puzzle, you know, and you're happy every time you find a piece that fits. So yeah, and of course, like we discussed last time, the MEP over or MEP over package is something I maintain. Yeah, so that's me.
Wonderful package. Make sure that video is linked down below as well. And last up, we have Sean Fruin. How's it going, Sean?
Hello. Good. Just talking
Tell
about
our
some of
audience
my
a little bit
favorite
about yourself.
things. Yeah, pretty much in a similar boat as Taco and Mej. Mechanical engineer, degreed, going for my PE soon, but kind of found computation and fell in love with it and realized it was the future. So that's what I've been working on consistently for the last 2 years. 3 years now, maybe.
Time flies, right? Especially when you're
Especially
having so
in
much
this weird,
computational fun.
yeah.
Yeah, definitely.
So, yeah.
Well, so speaking of that, and speaking of, computation kind of being the future, you want to talk on that a little bit? I mean, I think that within architecture, which is my background, architectural and interior production, there's a lot of room for design, for making things super pretty and picking different materials and different things like that, which makes, of course, documentation super challenging. Whereas with engineering, whether it's MEP, structural, different types of engineering, it's a lot of it is formula based,
Exactly.
right? I mean, you're designing a system around a building, and maybe you have different types of systems that you have to align to, right? Depending on where you are, or what the requirements may be in that jurisdiction, or whatever it might be. But aside from that, I mean, you're calculating flow and air and these types of things that are very formula driven, right? So it seems to me computation just seems to fit right in there.
I agree. I think it's kind of funny. Not funny, I don't know, right? Because when kind of Dynamo started taking off, it was all about architecture. Well, first it was about like really abstract geometry, right? And then we kind of saw this progression to a lot more about data and data management and shifting stuff. And a lot of it was on the architecture side. And I've always argued that like there's more of an opportunity on the MEP side, especially like generative design, and we don't need to get into formal definitions unless you guys want to, right? But just everything's measurable. Like you said, architecture, is it pretty? Is this material pretty? Like that's, objective.
Like form and function.
We're almost not everything, but almost everything in MEP engineering is you can actually get a formula to give you an answer. So
Yeah, I think that a lot of, all the formulas are already there, they're like physics-based formulas. It's been the same for, well, the last decennia at least. And what I think we're really trying to combat the shortcomings of Revit to make it possible, basically we're just trying to fit in these formulas that have existed for a long time and make them work for your software. And you get a lot of questions on those things, yeah.
Yeah, one other challenge about these formulas. So basically, we're living in a diverse world. So every country, every local authority has their own standards, and basically the physics is the same. But everyone wants to simplify the formulas because some formulas are not really numerically solvable. Or analytically solvable, and you need a numerical solution to that. So some people try to take a probabilistic approach to solve the engineering problems. Others take a more analytical approach. So you have your formulas that are a little bit different for every country. That's one of the things that is, I think, Autodesk have a problem with integrating into Revit, and that's where we play a part. So I have worked on, for example, on projects in several countries, in Germany, in the Far East, Thailand, Singapore, in the US, in Australia. So everyone has a little bit of a twist on those formulas, and you need to adapt your formulas to take every need. That's another challenge based on these formulas as well.
And it would be the same architecturally, right? I mean, for, even life safety codes and different things like that, depending on where you are, or, in Europe, maybe they don't even take into consideration those types of things. Who knows? Americans with Disabilities Act, these types of things that we have to comply with, which, like you're saying, is really hard for Autodesk to build into their software to compensate for all of these, not only the codes, but also the jurisdictional kind of manipulation, right? Where it's like, we're going to actually create an amendment to the code just for our county.
Right? I think that's the biggest challenge facing the industry right now. I wish I could hit up President Joe Biden and be like, build back better. You need to start with, let's do something with the code. Let's build, right? We need to take that part of it and bring that into the 21st century to where, I don't know if it is a government, right? You have upcodes kind of doing this, but how can we get all those problems in the building code and jurisdictions and all that in some type of form that works with algorithms? That's one of the biggest challenges I've seen. So,
especially with this giant infrastructure bill that we're
right,
seeing.
that's what I'm saying. So before
Right.
that, right, so just seeing it from the inside of the industry in and working on the automation, that's the first big stumbling block. So I don't think it's talked about enough. To me too, there's to do this, and I've been having this conversation a lot, there's knowledge. Like, we all talk about convergence of technology, right? All this stuff's coming together to make our lives better and do stuff. What I'm not hearing a lot of is about convergence of knowledge. And just for MEP systems, right, to actually build it, you need, and to do it in an algorithmic way, you need engineering knowledge. And this isn't just like going to school engineering knowledge. This is actually right. So to get your PE in the States, you have to work under a PE for 4 years minimum. And typically you're not stamping and sealing stuff until you've worked longer than that. So you need that knowledge base, right? That 8 years, 10 years of just doing this stuff, seeing problems that aren't really written out in textbooks, right? Then you have, how is it actually built in the field, the VDC side of things, the guys that are actually in the field installing this stuff. Right, whole different textbook, whole different book, whole different knowledge base, but that needs to be part of it. And then really to bring this all together, right, you need that computational computer science coding knowledge. And these three things need to come together. And it's a lot to come together. I don't know if there is one person out there that has all that knowledge. I haven't met them yet. I don't know. So, yeah.
Well, and what does that look like for tomorrow's engineer, people who are, in college trying to go through this path? And what would you give them as advice?
Learn how to code. I always tell, so I get some DMs, I get some DMs sometimes about people asking me what should I do out of school? And sometimes I have to take my own advice. I say shut up for at least a year and don't just try to soak in as much as you can, and learn from people, ask a lot of questions.
There's a lot of room now in our industry for even developers, computer scientists, data scientists, these types of people to really make serious change within our industry. Because of what we're saying, because of the computational drive behind a lot of this.
Yeah, and we need a lot more of those people, I think, and probably in the coming few years, there will be a lot more people, especially in the MEP side, who will start to code. I think maybe that in the architecture side, there is already a bit more. There are more people who have always been working with geometry and some form of maybe computational design, and the MEP guys up until few years ago have just been basically drawing lines, to say it in of course it's more than just drawing lines, but there wasn't really a computation side to it. So I think we are kind of playing catch up, you know, in that regard. And so there's a lot of potential for people who know how to code on the MEP side. So yeah, we need a lot more of those people.
That it also just seems baffling to me that it seems like it should be the other way around, right? I mean, because of the way that engineering is so formula based, you would think that it would be kind of at the beginning of the process, we're doing a lot of these calculations, we're figuring it all out. I mean, do you think that it comes down to just this is, you know, a lot in the way that we see architecture and in the slow migration to BIM or three-dimensional tools of this is the way we've always done it, and you know, we build buildings this way and it gets the job done? Like, do you think that there's just this adverse kind of mentality to change?
Yeah,
Definitely, especially in MEP, I've seen it a lot. We've always done this way, and we're sticking to that way. While I think the MEP industry needs to disrupt itself completely, because there are a lot of stuff that can be automated that are being done manually. A lot of stuff that are still based on standards that are like 50 years old and 60 years old, in a time where you can integrate a lot of artificial intelligence, machine learning. You can make a lot of use in the engineering field from IoT and digital twins to rewrite those standards and make them standards and common to everyone. So I think the industry needs to be disrupted because it's falling way behind.
I'm gonna start this with giving Autodesk some credit. So Autodesk obviously has a lot of smart people working for them. I put a lot of thought into the roadmap of Revit and where they're going. This kind of goes to a letter that was written a few years ago, or what, a year ago, whatever. To me, I think they are actually doing a good job, because I don't know, how do you, and Measure, I'm going to ask you this question, and Taco too. How do you make a tool that works for every code jurisdiction, right? Because as you do more code, as you get more specific on building type, location, right, the algorithms start to branch off to all these side rules. So it'd be really hard if you're a company, right? And as your market share gets smaller and smaller and smaller as you branch off into these specialty markets, school in New York, right? And what I think Autodesk has done well is with the API in Dynamo, there is the opportunity to customize your tools if you have the programming knowledge to tailor those tools to make it do whatever you want, essentially, right? So I do give credit to them on the API part and having that open. I don't know if you guys have thoughts on that.
I have mixed feelings. I feel like, you know, they definitely make it easy for us to share, and, you know, packages like MEP and Bird, you know, tools, things like that, that we can get really easily, the forums, the, you know, way that we can communicate through there and post problems, post, you know, solutions, etc. But because they put the onus on us, it's almost as though they kind of put, you know, it's like hands off, like, nope, it's on you, right? Like,
Yeah,
we're just
I agree with that part side of
gonna
it
do
too.
I think it's also maybe tied to the fact of liability.
Yeah,
right?
100%.
I mean, if Autodesk owns all of these formulas and things that are built into the API and all of these other things that users can use, like for me, you know, occupancy and all of that, that's how I got into Dynamo, and, you know, migrating that into plumbing calculations and all of that for minimum plumbing facilities. I feel like why is it that I have to do this? I know that there's so many people doing this, right?
Well, that's the thing. Are you doing it in New York? Or are you doing it in California?
Exactly.
Are you doing it
100%? The
in Lebanon?
California
Are you
building
doing Norway?
code and the, you know, the California plumbing code is so dramatically different than the international building code or the, you know, the other codes that we're using, NFPA, you know, those types of things that, you know, how is it that they would need a team, like you're saying, to allocate their time to not only working in these types of codes, but then every version, every edition that gets released, updating that and ensuring that, that to me
I
seems
guess,
like an.
And right now, why would they change, right? They have a monopoly on the
Right.
market, so.
Exactly.
And like I said, I do give them credit, right? They have given it to where we can do it. We can build automation, Forge, and everything. It's an interesting
Well,
question.
maybe
I
it's,
think the small startups, and how do they start to get market share, and how do they fix this problem? And is it possible? I don't know. I don't know. So.
Yeah.
Well, kind of the way when I'm creating a computational tool, especially being with Smith Group, which is multidisciplinary, I try to make it flexible enough to where multiple users can use it for multiple things, right? So maybe it's just a matter of building in the flexibility into the API of saying, allowing different types of inputs, and
Yeah.
those formula-based calculations are there, but you as a user have to go in and manipulate them in some way, or give it knowledge in terms of what the code you're using, what those numbers look like, what, all of that. But the infrastructure is there for it to be handled. I don't know.
I think the infrastructure is just a bit. I think that's part of the problem, that the API, it's not a modern API. It's really old. There are a lot of limitations, and I think that maybe that could be part of the problem, or part of the what that letter was about, is that the API is really old and you run into so many limitations. And if we are going on this, like open up the platform and let people develop apps for it, and in that way everyone can create their own local apps, or solutions. But then you need to have this basis that is, of which we can build, and right now that basis is just not what you'd like it to be, what it should be, I think. So it's kind of, we want to do this one thing. We want to have developers come in and build our specific apps, but there is also this limitation on the API side that doesn't allow us to do everything that we'd like to do. So
I always joke that's why I have a job, right? Because
Yeah,
of Revit's
exactly.
limitations.
So maybe we should look at it that way. At least we're all
Yeah,
making-
right.
I think you're kind of seeing that, right? With like things like Hypar and stuff, and other, there's a couple other people, but they're starting to try to fix those problems, and yeah, it'll be interesting where it goes.
yeah.
Well, stepping back a bit, Majdi, you said, IoT, the Internet of Things, and digital twins. I think the MEP related assets are really what owners and facilities managers, those types of things are what we typically see as COBie requirements and those types of things. They want to know what types of assets are in their building, whether it's the electrical panels or whatever it might be. And so is it that we need to start thinking about? Is it start thinking about the life cycle of the building and how owners can benefit from this type of computational knowledge?
I think so, yes. Especially in MEP, as you have all your elements are measurable through sensors or through some additional automation that is going through the life cycle of the building. So, and as long as you have your BIM and your BIM is fully compliant, why not give the owner access and have your BIM always connected to your BMS system, and always monitor your building, and have your any maintenance and operation always documented throughout the life cycle of the building. I think we're not too far from being there. Autodesk have introduced Autodesk Tandem last year, so that's one of the solutions that aims to get us to that point. But I think we're almost there. We should start embracing that technology. Have a BIM model through Forge being connected to a building throughout its life cycle. Monitor that building, have the maintenance, so every time you have a unit replaced, have it documented and in your BIM. I think we're almost there. I think we should embrace that. That would help us also. For example, Everyone, for example, let's say for thermal comfort studies, everyone has his own thermal comfort. It's relative, so someone might be hot while someone might be cold. And usually to be able to predict that, we run CFD simulations. So one thing we can do as well is have the room monitored throughout the life cycle of the building and see whether our initial CFD simulation or initial HVAC estimation, the layout of our diffusers is working. That would help us shape the standard, shape a new methodology to standardize the process and make it even more modern. And I think the new standard versions should be based on that procedure.
Makes complete sense.
Yeah.
Taka, what do you just say to that? Are we seeing that yet? I mean, are owners starting to ask for these types of things? Are they starting to be cognizant of the idea of what a digital twin is and how they can help in the life cycle of the building?
Well, I haven't run into any clients that come up to me and say, well, when my building is finished, I want to have everything monitored and connected to my building information model or my digital twin. So, I haven't run into any of those requests yet. But we are not that big a company. I can imagine that maybe one of you guys has, but I haven't. I wish I had. It would have been a nice little project.
I feel like it's kind of like BIM, right? Like 10 years ago or 20 years ago when BIM was this buzzword. It's like, yeah, let's do BIM. Owners are like, yeah, I want BIM. And they ask for BIM, they get BIM, they pay for it, and then it just sits on a shelf somewhere.
Yeah.
I feel like that's what's happened, right? I mean, even if they are asking for these types of assets and digital twins and different stuff like that, like what do they do with it? Do they know what to do with it? Are they prepared, the facilities teams, to work with this type of data? What does it even look like?
Is it a Revit model? Probably not.
Right.
So what is that? Yeah.
Yeah. And
and then there's a lot of issues with the manufacturing too, and how do you get all that information that you need, and especially how do you get all that information that you need at the beginning of a project, right? So my experience with manufacturers is they don't get involved until you sign a contract with them. They don't give you pricing. They don't give you, they kind of want to hold your hand, but they don't want to hold your hand until they're locked in. So maybe that's how you do it. Maybe you reach out to the manufacturers to have them kind of be a part of this, right? I think that's a critical step in the whole chain of events to build a building, right? It all starts with the manufacturing data. So what sensors are on the equipment? How do those sensors interact with the digital twin?
Yeah, I think the manufacturers are already doing this, and when they offer you like a DPFMO, like an integrated contract, where having those sensors and getting the data back will result in their own profit, So the incentive for them is perhaps bigger than for the building owner, or at least it's more, how do you say this, more direct, it's closer to them than it is for the building owner. Maybe there isn't even a technical manager for a client, but on the manufacturer side, there are a lot of technical people, and they have more. I can imagine that they have a bigger interest in doing this, especially when they have to do the operating and maintenance costs as well.
Yeah.
Yeah.
Well, John, kind of tying back to what you were saying earlier about, the VDC process and what's happening in construction. And, I think architecturally, engineering, I think all of us need to really look at that process of what happens when the design stops, when we as engineers, architects, put our pencils down and submit our construction set. Of course, we're going to have RFIs and deadlines and things like that, but the building's being built, right? How do we capture what's actually happening and convey that within the model that we're going to deliver at the end. It really has to be a collaboration.
If you're going to use, this is why I think automation is so critical. Because if you're going to manually, like there's so many components that go into a building. And there's each element, right, inside Revit has how many fields to fill out, especially if you're going all the way down to this level that we're talking about. There's no way that a team is going to manually fill all that out. This is like why automation is critical to get there. And I don't think you can get there without it.
And like you said, the fabricators being part of the process, everybody kind of having a hand in what that looks like.
Yeah, exactly. I guess it's kind of the big data, right? The big data conversation. It's a lot of data and errors in the data. Like if you manually do it, there's going to be errors in the data. It's fact almost, right? If I had to enter a whole bunch of, that's why I got into automation actually, is because like you asked me to enter 3,000 data points, like I'm going to be spacing out after about 100, and there's going to be errors, and it's just not possible. So,
Baja, what does that look like for you in terms of the tools that you're creating? How you're working with different companies and engineers. Are you seeing this type of thought coming into conversation?
Yeah, definitely. So when you work with different teams, and that's also tied to when your design stops and construction starts. So in addition to the different standards, local standards, you have different internal approaches each company has based on their own default contractor, based on their own process that they're used to do for a while. So you always have different approaches for every problem. Let's take the example of automating the routing of MEP elements. And you're automating let's say, connecting the pipes to a main branch. So every company has its own way to connect them based on how their contractor installs stuff, based on how they design them. So you have fitting layouts that are different, fitting families that are different. So that's one of the reasons that you see internal customization for each company. The problem of having stuff that are custom and trying to generalize that stuff is really our main challenge.
I think I want to add this because I wanted to say this earlier. I think it's crazy too, the spread of where we're at as an industry. Like you still have people and drawings and maybe the deliverables in CAD, but they're still on sheets of paper. One of my favorite stories was I got asked, huge building, to do the air balance table. And so we printed out the huge sheet. It was on my desk. And I was literally with a Sharpie going through and doing these calculations. And like, that's how they did it. And and then you have people getting into Revit and starting. And then you have like on the complete opposite end of the spectrum, right? The people that are us three, I guess, that are really trying to push the limits of computation way of forming it. But it's just all over. Like you it's probably a bell curve a little bit, right? But
it's funny that we can
where most people are just now starting to really embrace BIM, the idea of 3D modeling and
it's
funny. I think it's
definition of BIM
showing, getting people to find the value, right? Like
so,
how do we show the value of these types of tools? And it breaks my heart when somebody at Smith Group is doing something by hand and I'm like, but I have a tool that
tool to do it
would have saved you 500 clicks.
Something I've been learning more about, because I admit, like, I kind of rushed into this all. I was a little naive to like business practices, right? So I've spent the last 3 years solving problems. Well, if a company were just to pay me as an employee to solve that problem for 3 years, right, it's not really a good return on investment. So I guess the technology does have to mature a little bit before it makes practical business sense for firms to hop on it. But then the other side of the coin is, right, you have to kind of change the culture before it's too late. Or else you're going to be with those laggers, this guy AutoCAD doing the hand calculations, right? And not. So I think there's the economics portion of it too that has to play into the adoption and everything.
And I think that at the end of the day, you know, especially the design and the calculations, is just a really small portion of the total revenue for a contractor, for instance. So, you know, I think that's why they can also coexist, you know, the company where everything is done by hand, but at the end of the day, it's just a small portion of their entire revenue. So the urgency isn't always that evident, I guess, for the companies. At least,
yeah,
I
it's
can
a
imagine.
good point too.
Yeah.
And I think once again, it's what we saw with BIM, right? Until architects and engineering firms were losing work,
right,
and they couldn't win jobs because they weren't in Revit or using BIM or whatever it is, right? Like, is that going to be the same thing? Kind of like with my conversation with Marcelo, is it going to be like, oh, you're not going to win this project because you don't utilize computational tools? I hope so.
I think that's inevitable. It's just a question of like when that tipping point happens, right? So that's something like, to me, it's just interesting what does the future look like moving forward? Is it going to be small, nimble firms that are able to put a strategy together to be able to utilize data? I think large firms have a trouble like turning the boat. Is it going to be a software developer that does this? It's just because there's like Cove tools for energy analysis, and I don't know the privacy. And like, right, Autodesk, like they actually probably have a lot of data. I don't know the privacy concerns on it. I don't know what happens when you send your energy model up to like Insight for Autodesk. Like, do they have that? Can they use that? I haven't read all the fine print. Same with Cove tools. So they're collecting a whole bunch of information, just like Google is collecting a whole bunch of information about it. And yeah, it's an interesting question if they have access to that. If that's even a business side of the conversation that they're thinking about internally.
Yeah, and if they do get that data, are they able to, you know, understand it?
Exactly. Is it?
Yeah.
Yep.
How valuable is that data? It's a good question. Yeah.
Yeah, what are some of the problems that you guys face on a regular basis in this regard?
Well, Ceiling Grids forged me and Mej's friendship. That's a problem I was just frustrated with for years, and some chat on the Dino forum got me started, and then I handed it to Mej, and he figured out the rest. So. Another issue I see too is we tend to think, so like now I'm thinking about like laying out of systems and stuff. So like diffusers, lights, fire protection, whatever else goes in the ceiling, right? It's really easy if it's a rectangle, but most spaces, especially in Revit, like, right, most spaces aren't rectangles. Like they're these weird polygons, and you get into these problems that are really hard for a computer to understand. Like there's this disconnect I ran into a lot, and it's led into some really cool spaces, but where they're really good at recognizing patterns and shapes and like understanding where the center point of, I just think of all the Tetris shapes, right? So where the center point of a Tetris shape is. It's really hard to tell a computer where that is. And so that's an interesting problem that I love solving and thinking about.
Especially like a corridor that has a void in it.
The worst. It's the worst. I still haven't found it. That's another one. That's another like 3-year-long problem that I have. It's been on the back burner, but it's always back there sizzling. But like, how do you get the center line of a corridor? And if I were to put any Tetris shape or any weird shape, any human could be like, here's the center line of this, right? I think we all probably know what I'm talking about just by me describing it. But I challenge anyone who watches this, try to write an algorithm, even just by hand and paper, that gets you the center line of any polygonal shape. So that's a catch, right? It has to work on L-shaped polygons. It has to work on X-shaped polygons. It has to work on T-shaped polygons, and anyone. And it's very, very challenging, surprisingly.
Yeah.
Well, and
Combined
also
it.
the way that the API reports that shape. Is it a surface? Is it a solid? Is it lines that are bound? Is it right? Like, so I'd like to find one algorithm to find the center of a geometry. Like,
Well, here's another kind of hit on Revit. No offense, guys. Everyone, so if you look at all the generative design workflows that they've been putting out, it's get the surface of the space. Well, go into a production and use that method to try to get all the surfaces, and you're gonna run into self-intersecting line. Like, there's just, you can't get that geometry out easily. That's another huge struggle that I've ran into. That's frustrating, and it just takes a lot of computation, right? And it's all about I've learned, I didn't realize this at the beginning. There's this balance of, I know I'm not gonna use the right terms, but like execution time. Like, you always see the Q to the N. Help me out, Measure. Take go. Right, an algorithm, a certain
Big O,
speed
big
to
O
it.
notation. Yeah.
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 And if you're dealing with trying to fix geometry out of Revit, you're just adding up to the overall. And then we all know, like, Dynamo, for example, can only handle so much memory, and then it locks, has problems. So yeah, that's really frustrating. So the workaround is just to filter all that stuff out. But again, it's just another hurdle in Dynamo scripts and stuff.
Yeah.
So I guess that brings up one more, and then I'm going to be quiet on this topic for a moment. So most people think also that, like, a Dynamo script is an idea of, well, we're about the exterior walls one, right? So that's the idea of the Dynamo script. And that's honestly, I think, the easier part of writing a workflow, where the harder part is figuring out all the edge cases that don't work, filtering out all the instances where data is going to make your script fail. This sounded like John was on me, because again, John was kind of ahead of me. John Pearson was ahead of me on. It got called an argument, but it was a friendly conversation like a couple years ago where he was telling me this exact thing, naive at the time to realize it. But just writing a script isn't the hard part. It's testing the script, getting the bugs out, cleaning the data. Like, that's really the iceberg, I guess, the under the water part of a Dynamo script, of the iceberg analogy. You know what I mean? And like me and Mej talk, these are what we have conversations about all the time on just dealing with these issues, not the algorithm itself, but dealing with mining information out of Revit.
well, and even, talking to that point, how it's also very important the way that a user kind of works in sequence, right?
Exactly,
like, if you circuit
right?
to the high side first versus the low side, does the API spit out the data differently in the list? Right? Like, you almost have to
they
test
might
these
even
things.
think about building families. Like, where is your center point? It did the art, like, trying to just take stuff from. All right, the best one ever, because it's always different, is, all right, I have a wonderful algorithm to place fire dampers at fire rated walls. Where does that fire rated wall information come in? What parameter is it in from your architect? So how do you write a tool to do that? So all right, bring it all full circle. If I'm Autodesk, how do I write a tool to place fire dampers at fire rated walls when there's probably 1,000 different ways that architects label that information?
You have to provide an input for that label.
Yeah.
Which they kind of tried, right? Like, it's in there, but people don't use it. So, yeah, it's really interesting. It kind of brings it back, right, to the full circle of.
Yeah, how do we create an API for everyone?
Yeah.
Sounds good. An API for everyone.
API.
A universal API for everyone. That would be great.
Well, in Taco, I'm sure in the Netherlands, you probably come into different types of problems than we in the States do.
But yeah, I think this we face the same problems, you know, that there's such a diverse and multitude ways of input in your data, you know, like in naming and shape, and then there's also different input from different people. You know, you can get different for the same problem, you'll get different input depending on the person that is providing that input. And it's just so the diversity of the data, just the input is so big that it's hard to create something that will always work. So, but anyway, I think that's why Dynamo is such a great tool, is that it provides this functionality to easily modify your input and your workflow and still have something running, you know, if you would have to create a plugin or an add-in. You can do that as well, of course, but Dynamo really provides this quick visual feedback, you know, in terms of geometry or the list you get out at a sub step of your entire graph. So that's why when I create a plugin, you know, in C#, I usually first do it in Dynamo, so I can see all the little sub steps and see what's coming out of it. And that really
map it
helps.
out, right?
Yeah. Sometimes Revit will spit back elements that you don't want, you know. Oh, is that included in my query as well? And if I would have done that in just code, then, you know, there's a lot more digging through your code and finding that error afterwards. So that's why I really like Dynamo. It's really fast. It gives you fast feedback on what you are coding.
I'll add to that too. I mean, I don't think I'd be where I am I don't know if I would have taken the career path that I'm been taking if it wasn't for Dynamo. Right? It would have seemed like overwhelming to me to learn C# just to start building add-ins, where I'd probably be stuck in the conversation if this is the way it's always been done. But Dynamo really lowered the bar to entry into computational thinking for me personally. Like, geometry part of it, that's what I love about Dynamo. To me, I always make the analogy of like Dynamo is a lot like Excel, except you have the geometry, which is a whole nother side that you need to be able to do the engineering calculations. So
I think this is also a difference between architects and MEP people, you know, that the architects have always been working with geometry, you know, like lines and solids. And for the MEP side, Dynamo introduces us to these geometry nodes, you know, like before I started working with Dynamo, I didn't know exactly how a solid or a line or a point was represented in a software fashion, you know, in an application. So Dynamo has learned me a lot about those geometry, has learned me a lot about geometry, basically, in computer science. So that's really, really cool that Dynamo provided that.
yeah, to me too. I love the fact that to get an engineering degree, you have to like go through calculuses, and like Calc 3 is typically 3D geometry, and you're kind of using those skills still. Like, you're not actually doing the hard finding the tangent of a plane, right? But there's a node for that. But like, you're using those concepts that you learned. At least I'm using those ideas and those concepts that I got taught in college.
I like to think about the future also a little bit beyond Dynamo with Forge and all of that, which Dynamo is still not an option to get into. So Forge design automation for Revit, where you can run your entire automation on a cloud-based server. Basically, it's an AWS server that would run it way faster, would enable you to process multiple files, would enable you to mine data from your models. So that's one thing I've worked on with a local company here, and that we featured in AU 2020 last year. Mining data from Revit models through Forge, going through several models, gathering data, finding relationships through machine learning, through some fuzzy logic, trying to find new equations, new relations, trying to automate some stuff based on some artificial intelligence. Maybe if we still have some geometry, pure geometries that we need to gather to group, use some unsupervised machine learning to try to find patterns and group them together. That sort of stuff is, we're almost there, and we can start using them. Maybe not at a full scale, but at a smaller scale, at a take small tasks and try to integrate all these technologies: cloud computing, machine learning, unsupervised learning, clustering, and try to start automating small tasks. Once we have every task automated, we can try to start working on the big picture and try to automate everything. But automating small tasks through AI and the cloud computing, we're there now. We can start doing that, and I think we should start with that.
Taco, any final thoughts? Anything you want to share?
Yeah, well, yeah, I think that in the future, as I said earlier, I think that a lot more companies are going to have computational designers, you know, and I think Revit has kind of reached its limit in its current form, you know. You can see that all the cool stuff is going off into different software applications, you know, like Forge and Dynamo, you know. There's really of course Dynamo runs on Revit as well, but you know, these automation and the generative design is also done in the cloud, you know. So I'm curious as to where Revit will go, if it will stay in its place, you know, as just a kind of design tool, and then where is it gonna start and where is it gonna stop, you know, because at the start you have this more like a mass study, you know. You can do this in Revit and people do this in Revit, and then you'll start to get more like a bit more detailed, you know, where I think on every side of all those stages there will come more and more different applications that might, you know, take away a bit from what we do in Revit now, and because the applications will be a lot better and faster, you know, like gaming engines are evolving at such a fast rate, and you can do really cool stuff with it, and you can see that the API in those gaming engines is really modern, you know. You can basically do almost everything with it. You won't run into those limitations as you do with Revit. So I think there's going to be a lot of startup companies. You already see a few of them that are already trying to take some of their Revit pie, you know, like creating small buildings, and also on the prefab side, you know, creating a lot of prefab models in a more automated fashion on more modern software than Revit. So I'm really curious as to where that is going to go. And of course, Autodesk is really trying to keep up by supplying, you know, stuff like Forge and Dynamo and generative design. But well, I'm not. I don't know. I don't know if Autodesk can keep up with the, you know, the competition that's creeping up on every side, from every direction. Yeah. So it's interesting to see, and for us, really fun, because there's a lot of cool stuff to find out and learn.
Yeah, just
Revit.
ponder what tomorrow even will look like, right? Like,
Yeah.
what will be the next tool or the next, you know, thing that gets dropped by Autodesk or otherwise, by Bird Tools, right?
To what Tago said, I definitely agree with him about the gaming engines being way ahead, and I think our industry, the AEC industry, has a lot to learn from the gaming industry. So we need to embrace gaming technologies in the AEC industry as soon as possible.
Yeah, if you look at the new features that come out with, for example, Unreal Engine, every you know, the new features, they're just like really substantial, you know. And when you look at Revit, well, we can now schedule work sets, I think. You know, it's
Yeah.
yeah.
I mean, one of the
Totally.
things that can totally be taken right now. Collaboration. We still everyone has his local model and synchronize with Central and
Yeah.
reload latest. If you look at the gaming industry in 1998, you could play a multiplayer game online in real time. So I don't know. I think we're there. We can
Yeah.
include that right now.
Yeah.
At least collaboration, live collaboration, real time collaboration. So
Yeah, I ran across this new startup Majd, I believe it's called. And then they have this on Unreal Engine, based on Unreal Engine, and also they have on their roadmap, you know, 8-player simultaneous building. Wouldn't that be
yeah,
cool? You know, like have like multiplayer building design stuff. You know, that see people actually build those walls
yeah,
in real time. How cool is that?
yeah.
You know, yeah. It's
Minecraft, right?
Yeah,
like,
yeah,
yeah, exactly.
exactly.
Why not? You know, it's
I've talked to Dana and Mej about this. I want to see Super Mario Maker for MEP.
with
You
the same
guys,
sound effects.
sound effects would be great. Gamify as much as you can too. Like class detection should even be gamified. Like I think about that with video games too. Like what makes video
Yeah.
games so addicting?
I
Like,
want them to
and
give
they always
us
put these
explanation.
tricks, and you hear about it with social media and like how Twitter gets you into, you know, the slot machine psychology. It's like, how can we do that in the industry?
Yeah.
How could we see how many clashes you solved compared to your buddy? Because I guarantee you that would gamify it somehow and that would boost it up. But yeah, so a lot to learn from gaming industry.
Yeah. Yeah.
Yeah, let's make production goal oriented, right? Like,
Yeah.
you know, some sort of point system that you can win. Extra men.
Friday afternoon off if you get the most clashes throughout the week. Solved.
Right.
Talk about some motivation. Guarantee there's a return on investment there.
Well, I think that pretty much wraps it up. Super Mario and Revit and Dynamo are essentially my favorite things.
There you go. Bring it all together eventually.
Bring it all together.
Yeah.
Sean, any
Solve
other
our
final
2030. I'll just say from all this, we don't all know. We're all kind of confused about what the future holds. I'm gonna take a leap of faith and say I guarantee you the future is gonna hold some type of programming, a lot more APIs. So I just always encourage people just to start learning it. I know it seems overwhelming, but there's so many tools out there. Dynamo Forum, us, other people in the community. Don't be scared. It's crazy what's out and off of Giants. So
You're wasting time by not embracing it.
You
right?
are. It's find fun workflows and just start. Gotta start somewhere. So that's what I encourage everybody to do.
Yeah, that next task that you get assigned where you're like, oh my gosh, I have to spend 4 hours doing this.
I just want everyone to promise, never create sheets and views manually ever again, please. Like to me, then I always ask firms when they approach me, I'm like, are you guys automating project setup yet? And if it's a no, it's like that's where we start. So just find those type of easy, repeatable tasks, and you could find that information on the Dynamo forum in 2 minutes. So no excuses.
No excuses.
That's all I have to say.
Well, thank you guys so much for joining me today. Thank you everybody in the audience for listening in on Danamo Chat. And I hope everybody has a wonderful day.
Thank you.
Thanks, Dana. Thanks for having us.
Cheers.